All right. Folks, how's this warm-up going here, or this recalling? Going okay? All right. We're going to get going. So our learning goal for today is we're going to learn how to factor quadratics in this form, right, in standard form, where a is not 1, right, but also, more specifically, when a cannot be common factored out. So far, we've learned this is basically in 4.1 lesson, we've learned common factoring. And if you look in A here, the greatest common factor is, I believe it's just a 7, right? So what I did in 4.1 is I wrote GCF up here, and I put a 7 like that. And then what we're really doing is we're dividing each term by the greatest common factor. And we have to make sure to keep the greatest common factor out front, and we kind of just divide each term. So you'll have 7x squared plus 4x plus 2, right? Common factor of the 7, lovely. Now sometimes the greatest common factor is not just a term. It could be like a single term. It could be like a binomial or what we call the brackets. So in this example, notice that each of these terms have an x plus 3 in them. So we're going to common factor out the x plus 3. So we can divide this by x plus 3, divide that by x plus 3, and we keep the x plus 3 out front, and we're left with 7x plus 4. Now, that is truly what's going on here when you common factor out a binomial. But sometimes, in this example here, a lot of students I know that I've taught, and what they tell me is that they kind of take the math right out of it. So what they do is this. You ready? They say, oh, x minus 7 and x minus 7. I'm going to grab one of those, and then I'm going to grab these and put them in a bracket right beside it. Which is, I mean, it's fine. It'll work. But truly what's going on here is what happens in B. But if you wanted to kind of take the math right out of it, because you're finding that a little bit weird to grasp, that is a move that can certainly be done. Folks, any questions about common factoring? Okay. And then we moved into simple factoring. And simple factoring, now when we say simple, it's not necessarily because, well, it kind of is necessarily because it's a lot shorter than what we had thought. Because like I told you, we can do simple factoring the short way. We can also kind of do it the long way, right? So I think for the first one, I might just do it the long way, and then we'll do it the short way for the next couple of times. So what's going on here is we're looking for two numbers, right? And we're looking for two numbers that will multiply to positive 6. Oops. So like it multiplies to 6, but it adds to 5, right? And a lot of us are really comfortable drawing in this little table here that I saw when I went by. Let me cut that off there. And what you can do is just do all the multiples of 6. So 1 and 6. Sorry, I think it's negative 5. Whoops. Make this a little bit smaller. One and 6, negative 1 and negative 6, 2 and 3, negative 2 and negative 3, and I think that's the winner right there. Right? Negative 2 plus negative 3 equals negative 5. Okay. So in the long way of factoring, in the long way, we start off by saying, okay, x squared. Now, minus 5x is the one that is going to change into these two magic numbers here that kind of help us, that kind of satisfies our sum and product, right? So that minus 5x is now represented as minus 2x minus 3x. It's the same as minus 5x. Nothing has really changed here. Agreed? So what we do next is we group factor. We factor the greatest common factor from the first two terms and then from the last two terms. Group factor. And in the first two terms, the greatest common factor is x, and we're left with x minus 2. And in the second group, our greatest common factor is -3, and we're left with x minus 2. Now, to no shock at all, should we have here, when we have a common x minus 2, in fact, you know, if you factored correctly, if and only if, you have a common binomial here. That's how you know you've done it correctly. You're like, oh, okay, awesome, here we go. And then we just common factor out the x minus 2, and we're left with an x minus 3. Yeah. Now, because this is simple factoring, and because when we say simple factoring, we know that the a value is usually equal to 1, right? We could have just taken those two numbers, the -2 and the -3, and threw them in brackets here with the x as factors, x minus 2 and x minus 3, which is what we call short factoring, which is great. But truly what's going on here is this whole method of factoring. And today is the day where we're going to need this method of factoring when the a value is not 1. Yeah? Now, when you notice the situation where the a value is 1, right, that leading coefficient here, it's 1x squared, you're allowed to just go ahead and short factor. Like we can go ahead and do something like this. You know, something times something equals -20. The same two numbers added together equals +10. I believe those numbers would be 12 and -2, 12 and -2. Yes? Is that what it is? So what we could do in short factoring is say, okay, x plus 12, x minus 2. No, guys, help me out. What are the numbers? Let's satisfy the first one, not the second one. Are there numbers? Did you get numbers? Get some shakes? No, actually? Multiplies to 20. Oh no, you know why? All right, that one's not going to work. Back to the drawing board for mystery acquisition on that one. How about this last one here? We would say not factorable for something like that. Our first move. What would be our first move in something like this? Greatest common factor. Our greatest common factor, I believe, is -4. Okay. And we keep that -4 out front of the brackets. And we'll have x squared plus 1x minus, is it 12? Perfect. So can we further factor the things in the brackets here? Into what? What are the numbers that multiply to -12 and add to 1? What are they? Yeah. Yeah, -3 and +4. So we're going to turn this bracket into x minus 3, x plus 4. Now, the reason why we're able to go from this line to the next line is because, well, in our trinomial, the a value ended up being 1 in there in the brackets. So it was nice and simple for us to factor. So today, we're going to be faced with a situation of what if we were unable to common factor out the a value, right? So here, I know the a value was not 1, but it was a common factor. Thanks for that. But what's going to happen when we're met with a situation like this? We have 3x squared plus 8x plus 4. Now, notice we can't actually common factor out the 3 because the 3 does not divide evenly by 8 or by 4. So we're kind of stuck with it. So today we're going to look at 3 different methods. Actually, maybe even 4. There is a 4th one out there. We love it. It's great. It's called the Magic X. But in fact, I think it's too magical for us in grade 10. But maybe I'll post a video of it on D2L separately. Yeah? So we're going to learn decomposition, which is the first method, the box method, which is the second method, and then the guess and check method, the third one, which literally is just guessing and checking. So when we're met with this, our first question in factoring is, can we common factor? That's got to be the first question you ask yourself, because if you're able to common factor out that first a value, life is pretty good. It goes back to this last example in part C, right? Like it's a pretty sweet move when that's able to happen, but not every time it'll happen. So now our next move is to figure out two numbers that multiply not just to the last term, not just multiply to 4, but we say here multiply to a times c. And then the same numbers have to add to b. So we're still adding to b here. So our a times c is really 3 times 4, right? And that's 12. So we're looking for numbers that multiply to 12 and add to 8. So I go ahead and I just say, okay, 1 and 12, 2 and 6, 4 and 3, or sorry, 3 and 4, it should have said there. Do we have a winner? Do any of these add to 8? Yes, this is the one here that adds to 8, the 2 and the 6. Okay? So we're happy about that. Step number 2. So this would be, I guess, step number 2 if you want to write these out as steps. Number 3 is rewrite the b value. So rewrite that positive 8 as the sum of the two numbers found here. So think back to the long method of factoring, because this is actually it. We're taking, so this is step number 3, I suppose. We're taking the 3x squared plus 8x plus 4, and this 8x, that b value, we're going to rewrite it as, and it doesn't matter what order you put them in. You could say 2x plus 6x, yeah, because the numbers we're throwing in here is a positive 2 and a positive 6. You could put them, the 2 first, or you can maybe do the 6 first. It actually doesn't matter. It's going to work out the same either way. And maybe I can prove that to you on the board after this. So I'm going to put the 2 first. I don't know. 6 second, sure. So the first term here was 3x squared plus 2x plus 6, and then that 4 is at the end. And the same idea here, folks. We're just going to group factor the first 2 terms and the last 2 terms. So in here, oops, I forgot my equal sign. What is the greatest common factor between 3x squared and 2x? I think it's just an x. Just an x, because then we're left with 3x plus 2. And then the greatest common factor between 6x and positive 4, I believe, is just a positive 2, and we're left again with 3x plus 2. Now, notice, we know we've done factoring correctly if we have the same binomial here. That's how you know. Every single time. And that's not me rigging these up to do that. That's just math being magical. And then we just group them up here. So here we are. We're going to common factor out a 3x plus 2, and we're left with the x and the positive 2. Yeah? Now, maybe I should take this. Is that too much of it? I'm going to shrink this a little bit on purpose, because I want to show you, now you don't even have to write this down, but I do want to show you here what would happen if we reverse the order of the 6x and the 2x, because that's usually the most common question we get. So we're going to say 3x squared, and I'm going to put the 6x first, the 2x second. Yeah? Good? So we just reversed the order here. So, let me get rid of that. We're going to group factor here. Greatest common factor between 3x squared and 6x is 3x. Agreed? So we got 3x, and we're left with x plus 2. Okay. Greatest common factor here is a positive 2, and we're left with x plus 2. Notice, x plus 2 and x plus 2. We're really happy about that. We know that we've done this correctly. So we can common factor out the x plus 2, and we're left with the 3x and a positive 2. And if you look closely at both answers, they are both the exact same. Now I know one has the 3x plus 2 first and the x plus 2 second. This one has the x plus 2 first and the 3x plus 2 second. But I know you know that it doesn't matter the order, just like in simple factoring, right? Where we're multiplying two things by one another, so the order doesn't matter with multiplication. Folks, I could almost stop the lesson right now and assign you the homework and off you go, truly. Because I'm going to show you the three methods, maybe four, like I said, but a lot of the times, this is the one. This is the one where I talked to Mr. Todd last week, and Mr. Todd said, yeah, usually we'll start off with decomposition, coming from grade 11 to 12, and then Mr. Todd says he teaches something called Jedi mind tricks on how to factor these things. So I guess I won't steal his thunder in the next couple of years. Now, if that method is not for you, we have another method here. It's called a box method. Very similar to, I suppose, your science lesson, right? Remember that science lesson on Punnett squares? How you kind of set them up like this? Well, very similar to how we can kind of do FOIL, right? We set up FOIL like this. I showed you the window method. Well, now factoring is literally undoing FOIL. And if you look over here, like we've completely undid FOIL. If you were looking at this backwards, it's truly what we've done here is literally undo every single step of FOIL. So this box method, it's the exact same numbers here, right? 3x squared plus 8x plus 4, great. First common factor if possible, we can't. Find any two numbers that multiply to a, c, and add to b. So, right, a times c and b. Our a times c is 3 times 4, which is 12, and our b value is 8. And in the previous slide, we know, we'll give 1 and 12, 2 and 6, 3 and 4, and you know that 2 and 6 are the numbers here. Now, it says, write the first term of the expression in the top left. So, the first term, 3x squared, it goes there. Write the last term of the expression in the bottom right. So the last term here, 4. Okay. And add an x to the two numbers found in step 2. So see this number 2 and this number 6? We're going to add an x to them and put them in the remaining boxes. So we're going to say, all right, 2x and 6x. Okay, the two magic numbers here. It says your common factor the columns above and the rows to the left. If the first box is negative, factor out a negative. Okay, so what we're going to do here is just kind of common factor. So I'm looking down the columns. I'm looking at it like this right now. So the first column here, the 3x squared and 6x, the greatest common factor there would be, greatest common factor, 3x. Yeah? And then, so that's for this way. Now, how about the 2x and the 4? The greatest common factor, I believe, is a 2. Yes? Agreed? Now, we're going to look at it horizontally. What is the greatest common factor between 3x squared and 2x? I believe it's just x. And then what's the greatest common factor between 6x and 4? Well, I believe that's just 2. Yeah? So, what we're going to do is now these become our brackets. So we have a positive x and a positive 2, and we have a 3x and a positive 2. And if you notice, this is the same answer that we got from decomposition both ways there. And again, this is just truly undoing FOIL. We're just undoing. So FOIL was multiplying, right? Expand and simplify. And factoring is kind of just dividing. So when we get these common factors here, life is good. Yeah. Any questions? Questions about that? No? Feels good? Okay. Now this last method, it's called guess and check. There's some people in here that might just be so good at factoring that you could just kind of trial and error. So what I mean by that is, let's think of FOIL, right? We have A plus B and C plus D, right? We have usually four different terms here. Now, the result of the first term in FOIL is the F, right? So the way we get the first term has to be by multiplying, well, the first terms in the binomials. And then certainly this last term here, the 4, it's from the last move there, right? It's from the B times D. Because everywhere, the O and the I, those are the moves where you get, the common terms, the like terms. And you got to collect them, and that's where that 8 kind of comes from, right? So when we're setting up our factors here, we got to think that something times something has got to give us 3x squared. The first terms here, they have to give us 3x squared. So what are the only ways you can multiply to 3x squared? It's got to be 3x times x, right? That's literally 3 and 1 are the only multiples of 3. So it's got to be like 3x and x in no particular order. That's the only way you can get a result of 3x. You agree? Okay. Now, over here, these last terms here, how might we get a result of 4? Like 4 and 1? 4 and 1 is one way to get 4, but also 2 and 2, right? So what you can do is say, okay, positive 4, positive 1. Let's try that, But also, what you might want to try is 3x plus 2 and 3x plus 2. That's great. Sorry, x plus 2 for that second one. And when we say that those are our guesses, they seem pretty good, like pretty good guesses. Now when we check, well, we just check using FOIL. So we, for sure, boom, we get 3x squared plus 3x plus 4x plus 4. And when we bring this all together here, it's not 8x. We got 7x here, which we know that this one will not work. Yeah. Look, we got 3x squared, which is lovely. We got the 4, which is lovely, but the middle two numbers here did not actually add up here to 7. So we got to think. Here's another option. We got 3x squared plus 6x plus 2x plus 4. And this one feels a lot better. And if you check it, 3x squared, got it. 8x, lovely. 4, awesome. So you know that this is your winner right here. Now, guess and check, to be honest with you, I personally don't use it a ton. The only time I might use it, and I say might, because a lot of the times I won't, I'll just go to something that'll work, like decomposition. But I usually, it's a great method when your A value doesn't have many factors. So like when it's a number like 3 is prime, 3 times 1 or 1 times 3, that's a good time to maybe think about using guess and check. But also when negatives get involved and things like that, it can get a little spicy. So not sure if this is a method that you might want to, it's certainly worth trying it, but I don't know if it's something you're really going to get into it. I think the past couple of years I've taught in this course, maybe like 3 or 4 students just fell in love with it and did it forever. Okay. Now, last example here, or last examples, maybe I want you to try. Maybe I want you to try to factor these using the method of your choice. Like, for example, this first one here, I probably would not use guess and check because it's 4x squared. Could be 1x and 4x or 2x and 2x. Like, who knows? But give those a whirl, and we'll take them up together. You know what, maybe just try the first one, then we'll take it up here. All right, let's try this one. We're looking for numbers that multiply, or a times c multiplies to a times c, which is 4 times -5, which is -20, and adds to b, which is -8. So what multiplies to -20? Well, I'm thinking 1 and -20, -1 and +20. How about 2? So 2 and -10, or -2 and +10. 3 will not work. 4, 4 and -5, -4 and +5. And I think that pretty much all of them. Now, which one of these add to -8? Not you. Not you. Oh, yeah. This is our winner. Agreed? 2 and -10. Okay, so what we're going to do is we're going to break up this middle b value into a positive 2x and a -10x. So then we're going to add on our 4x squared. Oop, that's kind of a little low. Our 4x squared will go here, and our -5 will go at the end there. Yeah. Now we group factor. What's the greatest common factor between these first two and then the last two? So we got 2x, and we're left with x plus 1. And then we got -5. -5. 2, oh, that's why. It's not x plus 1. It would be 2x plus 1. Whoops. -5. And 2x plus 1. And that's the beauty of that. Noticing that the two binomials have to work out here to be the exact same thing. I knew I definitely had to made a little small error somewhere in here because they weren't matching up. So we're going to common factor out at 2x plus 1, and we're left with 2x minus 5. What do you think? Try another one? For sure. Questions, actually? Questions about this one? Yeah. Where did the 2x plus 1 come from? Great question. Well, when we look at the first two terms here, right, our greatest common factor between 4x squared and 2x is 2x. So we divide this by 2x, divide this by 2x, keep the 2x out front of the brackets, and our result from dividing would be 2x plus 1. Okay? And that's the same thing here. Our greatest common factor was -5 and -5. So when we divide each term by -5, keep the -5 out front, and we're left with 2x plus 1. That was a great question. Okay, B. Let's try B. multiply A times C. A times C is really 3 times 10, which is 30. And then our B value is just negative 17. Now, some of you can already just see this. You already know what the numbers are. But if not, that's fine, because you can just do all the multiples of 30. Now, with factoring, you end up getting like little tricks here. We're multiplying to a positive number, right? We're multiplying to positive 30, and we're adding to negative 17. So that should give us some indication that for sure both these numbers have to be negative. So negative 1, negative 30, negative 2, negative 15, negative 3, and negative 10. 4, no, negative 5, and negative 6. And then I think we just go backwards from there, yeah. So which one of these will add up to negative 17? I think it's this one right here. Negative 2 and 15. Oh dear. Okay. So 3x squared, and then we're going to use minus 2x minus 15, right? This negative 17 gets broken up into those two. And we have this plus 10 at the end here. So we haven't really changed the trinomial a whole lot. We just re-represented the b value as the two numbers that we know will make this thing work. So now, here we go. Here comes, actually I'm going to leave some more space here. Here comes the common factoring bit. What's the greatest common factor for the first two terms here? We got 3x squared and minus 2x. What's the greatest common factor for those two? 1. Now, how about the variable? 1x. So 1x divided by 1x. We're going to keep the 1x out front of the bracket. And then when we do this, 3 divided by 1 is 3. X2 divided by x1 is just x1. And then the x's here will cancel. 2 over 1 is just 2. And the next two, well, we got minus 15x and positive 10. And I told you, whenever you see a term that's leading and it's negative, try to common factor out the negative. So for something like this, we'd want to common factor out the negative. And I think it's going to be a negative 5. So we're dividing this by negative 5 and this by negative 5. Keep the negative 5 out front. We'll get 3, positive 3x, and then a negative 2. Now, we're going to common factor out the 3x minus 2, and we are left with x minus 5. Folks, questions? Questions about that second one there? B? So far, so good? Yeah? Okay. Okay, let's try this one. 6x squared plus x plus 2. So our multiplying to a times c, which is really 6 times negative 2, which is negative 12. And then our b value. What's our b value? Is there even one there? It's just 1. Yeah. It would be positive 1. So what multiplies to negative 12 and adds to positive 1? Well, there's only one way to multiply to a negative number, and that's if one term is positive and one is negative. So 1 and negative 12 and 1, 2 and negative 6, negative 2 and positive 6. Sorry, I wrote the same one there twice. I didn't mean to do that. I meant negative 1. Negative 1 and positive 12. Okay, we got the 2's done. The 3's, 3 and negative 4, and negative 3 and positive 4. Six. I think that's all of them, because I think they just kind of go backwards after this. So which one of these adds to 1? Positive 1. Oh, here we are. That's the one that adds to positive 1. So what we're going to do, we're breaking up this middle term here. So we got 6x squared. And then we're going to go minus 3x plus 4x minus 2. Notice that if this was negative 3, we're putting in a minus 3x. This is positive 4, we're putting in a plus 4x. In no particular order. Now, if you found it easier to put the 4 first, sure, then you can put the 4 first. But when you get really comfortable with this, you see 6 and 3, it'll be nice common factors. 4 and 2 will be nice common factors. So using that order would be better than the opposite way. Yeah? Now our greatest common factor for the first 2 terms is going to be 3x. So when we divide both terms by 3x, we're left with 2x minus 1. And then the greatest common factor for the last 2 terms, I believe, is just 2, positive 2. And we're left with 2x minus 1. And we know we've done this correctly when we have 2x minus 1 and 2x minus 1. So we go 2x minus 1, 3x plus 2. Lovely. Folks, any questions? Any questions at all? No? It's going okay? None? Okay. Last one here on this kind of a trick. Do you see why it's tricky? The first question we have to ask ourselves when we're factoring is there a greatest common factor? And if you look closely, there is. There is. The greatest common factor here would be 2. So when we common factor out a 2, we are left with x squared plus 4x minus 5. And this is a scenario that we just love. We hope this happens every single time because now we're just dealing with, if you look in the brackets, we're just dealing with simple factoring. So we can always go back to our roots here from last week and think of 2 numbers that multiply to negative 5 and the same numbers add to positive 4. And I think those 2 numbers would be 5 and negative 1. 5 and negative 1. So remember, we got to keep the greatest common factor out front. And this trinomial here in the brackets will factor into x plus 5 and x minus 1. Again, short factoring, yes, of course, because we love when the a value is 1. When a value is 1, short factoring all day. Folks, any questions at all? How do you feel with this? 5 is like, yeah, hurry up. 1 is like, I don't even know what I'm doing. I don't even know what's going on. Can you give me a little check-in close to you so no one else sees? Okay. All right. And the last one here. A's and B's. I hate when they're A's and B's because I always write X's. It's going to happen. So it says here, look for a common factor first. We're like, all right, sure, no problem. So this first one looks kind of scary, but is there a greatest common factor? Yeah, I think it's going to be 3, positive 3. So we're going to say, okay, 3 in our trinomial. What's this going to look like here? A squared. I know. I'm gonna write x at some point, so just be cautious. Minus a, 1a, right? Minus 1a, minus 5. Agreed? So we common factor out a 3. And now, if you look in this trinomial, it's not a pretty one. And when I say not a pretty, I meant not a simple one, right? Like when we factored it out here, we're like, woohoo, we're pumped about that. But this one, we're like, oh, okay, all right, here's what we're dealing with. So we build our little chart here. 6 times negative 5. negative 30, negative 30. So we're trying to multiply to negative 30 and add to negative 1. Yikes. Negative, no, we're going to start off with positive 1 and 30. 1 and negative 30. Negative 1 and positive 30. Does that work out? No, no. How about 2? 2 and negative 15. Negative 2 and positive 15. Does that work? No. 3s? Oh, yeah. 3 and negative 10. Negative 3 and positive 10. Does that work? No. Uh-oh. How about, what's next? 5s? 5 and 6? 5 and negative 6? Or negative 5 and positive 6? Does that work? Oh, yes, it does. This is the money. Now, which one is it? It has to be this one. Has to be, because we're adding to negative 1. So the negative number is going to be the bigger, but really smaller one here. Okay, so now that we have the numbers that'll work, this is where the greatest common factor becomes a little bit of a pain, because we don't want to forget about it. It's still here. It's still here. It hasn't gone anywhere, but we kind of just do the question, the rest of this question, just inside of these brackets. So we know the first one's 6a squared. And we have, now, I think, and you might think this too, I'm going to put the minus 6 first. Do you see why I'm putting the minus 6 first? So it'll be a lot easier to factor later on. And then I'm going to go plus 5x. And then the last term here is minus 5. Like, should we have put the 5x first? Like, sure, it would work out, but it wouldn't work out as simply as this one is going to. So, keeping that greatest common factor out front, we are going to group factor. And so I put x's. Look, there they are. My bad. I'm sorry. These should be a's because the variable we are dealing with is a. I knew this comment at some point. We got it. So greatest common factor for the first two terms is a 6a. And we are left with a minus 1. And then the greatest common factor for the next two terms is a positive 5. And we are left with a minus 1. And we're really pumped. We're really pumped about that. Because if you look, a minus 1 and a minus 1, we know that we are in the right direction here. So we can write this as a minus 1 and then 6a plus 5. And this looks like an awful lot of brackets. And this would be a fine answer. But really what you might see at the back of the book is this, which is the same thing here. But the reason why I wrote it like this is because I wanted to exaggerate that greatest common factor being out front. And it's just so much easier to write it when you have it set up like that. So, folks, any questions about that one? Because that's about, truly, that's about as tough as factoring will get. This right here. This is the hardest factoring to do. So after this, like that's as hard as it can get. They just get easier. Okay. Folks, last one here. First rule of factoring. Do you see a greatest common factor? 17 is prime, isn't it? There's no greatest common factor. B cubed, B squared, and B. I feel like we can common factor out a B. Yeah? So we're going to say divide this by B, divide this by B, divide this by B. We're going to keep the B out front, and we get negative 5b squared plus 17b minus 6. Couldn't common factor anymore. Oh, folks, I'm going to backtrack just one step here. Sorry. I'm noticing that the first term here is negative. So because of that, we should essentially common factor out a negative b. Sorry about that. So when we common factor out a negative b, we should be left with positive 5b squared minus 17b plus 6. Yeah. So, what are the two numbers here that a times c is 5 times 6, which is 30, multiplies to 30 again, but this time adds to negative 17. Does anyone know those two numbers just off the top of their head? Yeah? Negative 15, negative 2, that's the winner. So, negative b, and here's our giant brackets here. 5b squared. Now, which term do you want to put first? The negative 15 or the negative 2? Which one would be the easier one to put first here? Probably the negative 15. B minus 2b plus 6. The reason why is because, well, we're dealing with 5s and 15s for the first set, and then 2s and 6s for the second set. So it's just a lot easier. So we get here negative b, and in brackets here we'll get greatest common factor of the first two would be 5b, and we're left with b minus 3. And the greatest common factor for the second two is negative 2, and we're left with b minus 3. And I always set up my next line like this, just so I don't lose track of the greatest common factor. And we're going to common factor out a b minus 3, and we're left with 5b minus 2, close the bracket. And then if you want, you can just get rid of the big brackets. b minus 3, 5b minus 2. Okay? Wow. Folks, this is the hardest bit of factoring right here. This one, those are tough ones. Any questions at all? Who's thinking of just sticking with decomposition? Who's saying guess and check? Who likes the box method? Anyone like the box method? All right. Okay, that's all we got here. Our homework is assigned at the bottom. It's also in the front page of our, it's not on your bottom page, it's on mine. But we got some work to do here. And this is some really good homework to complete.